How's it going, everyone? Darren Ruan here and welcome to CodeGaff. The highlight of this week's video will be the beginning of the implementation of my enemy AI. But before we get into any of that, if you're interested in following me along on this 10 out of 10 epic game dev journey, then make sure to subscribe to my channel and hit that little belly button to get notifications of my latest uploads. So it is currently Monday evening and I've just gotten home from work. I decided to kickstart this week with the most fun task of all time: bug fixing. I noticed some strange behaviour last week with collision, namely when a collision would occur in the game at a certain angle, then a constant force in the opposite direction seemed to always be applied. You can't really see it happening here because it's too slow, but thanks to a sophisticated and magical power that only I possess, I can speed up time and allow you mere mortals to see the bug in action. It turned out that this was due to the fact that no dampening was being applied to the linear drag of the player's rigid body. I couldn't find any information on what a reasonable amount of drag is, but since I didn't want any sliding to occur at all, I decided to just max that bad boy out. The other thing I wanted to do was to allow the hedgehog's hurt animation to transition to itself, because there can be times where if the animation is in the middle of playing and the hedgehog is attacked again, it just won't play the next one at all and it kinda looks like you didn't really hit him at all even though you did. That was a simple one checkbox change, but it made a huge difference, as you can see here. It kind of feels more responsive too, seeing as the hedgehog will restart the animation even when it's halfway through the previous one, as opposed to kinda waiting until the end of the current one to trigger the next. And the last thing on my list for the day was to deal with the strange overlapping of sprites that can occur when two dynamically sorted objects are perfectly aligned on the y-axis. This is something that is extremely unlikely to ever happen during gameplay, but it's been annoying me just to know that it can happen, so I wanted to do something about it. It was actually a really easy fix to implement thanks to Unity's sprite group component that I recently learned about. And with that done, I checked in my changes to Azure DevOps and closed off yet another task. It is now Tuesday and I've just fixed a fairly major flaw that I discovered by sheer accident. My attacker script would attack once for every single attackable collider on a game object that gets attacked. This was obviously not intended, so I've fixed the issue now, as you can see here. If I go ahead and add a load of colliders to the hedgehog and then start up Unity and attack him, take a look at his health here as I do it, you'll see that it goes down by 1 even though my weapon is actually colliding with multiple colliders. So I checked those changes into Azure DevOps and closed off the bug. Nice. Since I was in the attacker component to fix that bug, I decided to make a change that I've been wanting to make since I added combat a couple of weeks ago. I wanted to make it so that something can only be attacked when the attacker is aligned horizontally with it. As you can see here, and you might have probably noticed from previous devlogs, Skelly can actually hit the hedgehog and this wonderful treasure chest even if he's nowhere near them. It looks super unrealistic and it also just doesn't fit into the sort of gameplay that I envisage for this game. So I added a filter to remove any colliding objects that aren't aligned horizontally with a little bit of a tolerance just to kind of make it a bit more realistic. Here's how that looks. The tolerance makes it so that you can still hit things even if you are just slightly below or above them. I think this works really nicely and definitely feels a lot more natural and intuitive now. It is currently Thursday and I'm about to finish up for the night, but I thought I'd update you guys on what I've been doing for these past 2 days. I've been learning about behaviour trees for AI implementations and I have to say, I am so goddamn hyped to start implementing them. I seriously can't wait to bring the hedgehog to life. I came across a load of helpful articles and videos during my research, but if I had to pick just one to share with you guys, it would definitely be this one by Chris Simpson. It's a little bit on the old side now, but it's still super relevant and really opens your eyes to the realm of possibilities that behaviour trees can enable. There's a link in the description so you can check that out if you're interested. Up until now I'd only really heard of behaviour trees but didn't actually know what exactly they did and how they worked. Now that I do understand them though, oh man, they're so cool, seriously like. But I'm gonna go eat some dinner now and get cracking on the implementation tomorrow. Okay, it's now Friday evening, I just got home from work and I have to say I've been itching all day to get started on this behaviour tree implementation. I figured that I might switch over to an established behavior tree plugin like Behaviour Designer sometime in the future, but for now I really just wanted to deep dive into them myself and I guess kind of assert that I actually did understand how they worked after all that research. So I created the typical nodes that you'd expect from behavior trees, composites, decorators and leaves, and then I went and thought a bit for a while about how I wanted the actual tree building syntax to look. I saw a really cool repo on GitHub that uses a Fluent implementation of behavior trees, which I really like because I use ASP.NET Core at work, which makes heavy use of the Fluent design pattern, so this was very familiar to me. However, I don't think it's an appropriate fit for behavior tree building. Fluent design is intended to make code more readable by closely resembling naturally spoken language. It relies heavily on chaining methods to achieve this, which is an inherently linear process. It doesn't really fit very well when you have a hierarchy of commands that need to be executed, especially if they can nest in quite deeply. So after thinking a bit about it, I came up with my own solution, and it allows me to build my trees using what I think is a far more intuitive style. Here's how it looks. You can see here that I've created some keywords which basically just wrap around the behavior nodes. Any is just a selector and all is just a sequence, but I think it reads a lot nicer this way. What this basically does is, since this is just a selector, it will run each child node until one of them succeeds or they all fail. So essentially it'll try to run this sequence node, but if it fails for whatever reason, it will run the next node, which for testing purposes just prints out a message to say that it failed. But should the sequence not fail, should it actually succeed, here's what it'll do. It'll print out to the console that it's moving to the target. Then it'll actually move the hedgehog to the skelly's position. Afterwards, it'll print a message to say we arrived to the target position, and then we'll wait 3 seconds. And finally, it'll print a message to say that the sequence has finished. Now, if I were to write this behavior tree out using the Fluent pattern, it would look a bit like this. Not quite as intuitive, I think, but what do you guys think? Let me know in the comments below. Anyway, with this basic first version implemented, let's have a look at it in action. So as I move Skelly around, you'll see the hedgehog follow him until it finally arrives at his position. And if you look in the console, you can see the debug messages being printed out. The hedgehog waits 3 seconds, and then when the sequence finishes, the whole thing gets repeated again. But let's have a look now at what happens when the sequence fails. Now, one of the fail cases is when the pathfinding script gets disabled. So if I disable that now, you'll see that the hedgehog will stop moving, and instead of what it was printing out before, we now get a bunch of messages in the console saying that the sequence failed. How cool is this, man? By composing a behavior tree with small, simple, self-contained behaviors, you can create some seriously complex AI. Right now, of course, that is not the case because I haven't actually implemented those small, simple, self-contained behaviors, but that's exactly what I plan to do next week. And with that said, that marks the end of this devlog. As I just mentioned, for next week I will be focusing on adding new behaviors to my behavior tree library, and then hopefully building some cool behavior trees with those. I'll most likely have the hedgehog attack the target when it arrives to its destination instead of just waiting for 3 seconds. So yeah, thank you guys for watching, and I will catch you next week. Oh, and if you're not already a subscriber to my channel, then you should definitely subscribe now and hit that little belly button so that you can stay up to date with my latest uploads. Cheers!